Okay, in this application, I'm going to show you how to use depth check to achieve a grade and sustain that grade. And for this situation, we're going to be using laser. The difference about this task, or this application, is that unlike the prior two tasks we've shown, I don't have a known surface to touch with the tooth. I don't have a known grade to bench off of with the tooth. So just a little quick background on the job. This is imagine if this is a building site that's I'm reading the drawings, and the drawings are telling me that I need footings scattered throughout the plot that are at 16 inches below base grade. We've been told where base grade is. We've set up our beacon at 60 inches above base grade. I'm going to go into the machine and turn the laser on, and that again is accomplished with the depth target screen. The number 7 button turns the laser on. Now the other thing I have to do now is establish my depth target, and I'm going to set that at 76 inches, which I've preloaded. And the reason it's 76 inches because the drawing calls out the footing, the bottom of the footings at 16 inches below base grade. I have my beacon set up at 60 inches above base grade. In this application, we will be benching off of the laser signal, the beacon signal, as opposed to the surface. And the system takes over after that and calculates and provides the distance from the laser beacon down to my bucket tooth. And so we'll be digging in the same fashion. Once I've benched off of my beacon, I'm done with the laser, and depth check takes over after that, and I follow the guidance of the depth check just like you did on the past two examples. So I'm going to raise up, catch my beacon signal. I have a solid green light. We're using the BLR2. At that point, I'm going to reach down and bench. My machine is positioned, it's planted, my blade's down. I will not move the machine after this point. Now, I will dig, much like we did before, a gentle peeling off the surface so that I don't jar or move the machine. That throws the system off. I am starting to hear my my warning zone, which tells me I'm approaching my 16 inches of depth relative to base grade. So I'm going to dig a little slower. And I'm continuing to strip, careful not to exceed my depth ideally. Briefly, I hit target there, you could hear. And I'm going to try to make my final pass on this pass. I've got solid tone. Trying to sustain solid tone all through my last pass. And I'm pretty comfortable. So now it's time to move. And of course I'll raise my blade. I will back up to where I can still reach my unfinished trench. Plant my machine, blade down, get myself stable. Now I need to rebench, so I need to catch my laser signal. So I'm going to go down and raise up slowly. I've got solid green light on the receiver. I will rebench. Just like the other applications, every move requires a rebench. And I continue the digging process. And so what the laser addition does for me is now I can move all throughout this job site, and I can dig footings or pads at exactly the same depth, even though I can't touch or reference off of those other pads. And the fact that as long as I can receive my beacon signal, so it's important to set up your beacon appropriate, I can dig and match trench bottoms anywhere I can receive a beacon signal. So we've talked about basically 3 different styles or applications of depth check today. Minimum cover with depth check, sustaining a grade with depth check, and then we moved on to actually achieving and sustaining a level grade with depth check and a laser. Now, a variation of that might be if the task calls for a slope in the trench, and that would be, for instance, maybe installing a drain field septic system. Now, that's easy to do with a laser. All we would do, instead of for our sustaining and achieving and sustaining a grade with the laser, what we just did, I had my slopes, of course, at 0. If I wanted to sustain a 2% slope, I simply dial that into my beacon, and then depth check will follow that 2% slope as we continually bench away from the beacon.